It's 5:15. I think we should get started. Looking at the amount of people, I don't know if I should be surprised or feared or be afraid. I don't know. Thank you very much for being here. I know it's the last session of this amazing DrupalCon. Thank you for the respect. But let's get through it. All right. Context, intelligence, actions. Quick question. Who was there, DrupalCon Lille, 2 years ago, 2023, where Dries, okay, a lot of people, he told the fairy tale of how Drupal had to grow and how it should look at improving its usability, or how Drupal is trying to advocate for the open web and how it should strengthen its marketing efforts. Because there was a problem back then. We had to improve, we had to change, we had to adapt if we want to be still in the same market as a WordPress, as a Wix, as any of the other open source or closed source CMS platforms that are out there. Because we as a villagers, or the people that are creating Drupal websites, we were not satisfied. The improvements or the new features were not coming as fast as we need them to be. So Drupal left on a journey looking for ways to improve, and he encountered other platforms like Reactopia. Everything was inaccessible for less technical users, but apparently developers loved it. He also encountered Contentville. Everything was proprietary but easy to get started. SquareX, right? Everything was limited but easy to build and update. And then, of course, Adobe Heights, still find it a really cool name, but everything was very expensive, but it was powerful. In the end, he returned with a lot of knowledge and a lot of ways on how it could adapt Drupal Village, just by simplifying the way the villagers could handle creating, expanding, and maintaining a new website or a house. And that's all good, and that's all fine. For the villagers, but we cannot forget that those platforms, they will still be there. In the next couple of years, a WordPress will still be there, a Wix will still be there. So we need to continue looking for ways to connect with them, to collaborate with those platforms, and not just steal their ideas. We need to make sure that Drupal is the platform that is the de facto standard, but that the other ones can still grab content from us or grab functionality or execute stuff on the Drupal installation. Because that's where true innovation comes from. It comes from unity and shared knowledge or shared functionality. So let's continue our fairy tale. One day, Arthur Icarus, it's a made-up name, he walked into the village, and he introduced the villagers to a magical door that he named the Mighty Crystal Portal. If you get the abbreviation, you know where this is coming from. So this door had the power to bridge the gaps between the different villages, between the different frameworks and platforms, and allowing them to communicate and work with them. So with that doorway, Drupal could expose its own capabilities to the other villages, but also harness their strengths, right? So in the end, or as the villagers of Drupal embraced the portal, they began to see the true potential of their collaborations. So Arthur Icarus, the mage, the AI, he became the guiding light, illuminating the path to the connected villages. So if we come back to this presentation, this means that Drupal's AI module, powered by MCP and in my opinion ECA as well, enables the villagers to integrate AI functionalities from various sources, so not only from Drupal itself but from other platforms as well, and create an harmonious ecosystem where every village contributed to a greater whole or to a greater platform or to a greater product that we want to provide to our clients. So today we embark on a journey through these different mountains, through these different villages, exploring how Drupal, with the help of ECA and MCP and AI, is forging pathways to true innovation. And we're going to see how AI-driven workflows with ECA can automate processes, and also how it can provide intelligent interactions, transforming these beautiful landscapes. So I invite you to join me as we climb these peaks and we discover the true power of collaboration. So, hello, my name is Jasper Lammens. I'm a Drupal developer slash solution architect at Drupal. We're a company, Ghent, we're also one of the diamond sponsors here. And yeah, we do these things. I'm not going to explain you that. If you want to know more about what we do, I want to say come to our booth, but I think we're at the end of the DrupalCon. I think it might be gone when I reach back to, when I go back to the big hall. So yeah, I would also want to say grab a waffle, but they're all sold out, so sorry for that. I'm gonna remove the slide. I'm also very passionate about energy management and smart home, so this is also a presentation that I gave the last couple of years. It's about how we use Drupal to make sure that whatever my solar panels are producing, I can optimize the usage of them by scheduling smart appliances and stuff like that. This is our overview of today. We're going to talk about ECA, how it's what AI can do inside ECA. Going to talk about AI agents, not as much as I would want to. Marcus already gave a presentation about that, so he's the expert in that. We're going to talk about tools, MCP, summary, and then of course Q&A. There will be time for questions. I don't know if I have time for answers. We'll see. So, intro into ECA. ECA stands for the Event Condition Action Module, right? It's created by Jürgen. Sadly, he could not make DrupalCon due to private reasons. I would have hoped to talk to him, but sadly, yeah, life turns a different way. So what is the Event Condition Action Module? It's a rules engine, and basically it listens to when certain events are being triggered inside your application. And with events, I do mean the ones that come from the Symfony layer, like Symfony events or Drupal events. You can create or you can attach different things to them. We're going to see that in the next slide. But it's at its core, the main reason is that it's being built by things that are already inside Drupal core, like actions, like conditions, like your events. There's nothing new about them. Those are the building blocks, the plugin types that are already in core since I think 8 or 9. If you integrate that with a graphical user interface like bpmn.io, the one that I'm going to use inside the screenshots, or Incamunda, which is another proprietary application, you also have the ECA Classic Modeler. Nobody ever used that. I wouldn't recommend it either. We're also working on creating a UI via React Flow. It's also very popular inside the JavaScript community. That's something that my colleague is working on. And since a short while, you have the Modeler API, because in the past the UI and the data model of ECA was tightly coupled together. We now have the Modeler API that sits in between, which makes it possible that not only the left side of the Modeler API, like the data connection or the data model or the configuration, like an ECA model, can be split from the UI. So you can have in the near future a UI via BPMN, which then controls, for example, a migration. So you have, a migration.yaml file. It's very clunky, it's not user friendly. If you put a UI in front of that, that would work together through that Modeler API. So how does the Event Condition Action module works, or what are its components? As I mentioned, it are things that are already in core, like events, for example, when a user logs in, or when a node is added, or when a form is submitted. A condition, those are things that need to happen or that need to be validated before the other end of the connection is executed, which is the action, of course. Again, these conditions, if you don't know what they are, you should if you are placing a block inside block layout and you want to determine whether it's on a specific page or for only visible for a specific user or for a specific role, stuff like that, those are those conditions. Then you have an action, which is basically an operation that you can perform. Examples are sending an email, providing a body field, or triggering another workflow, triggering another event. That's all possible. This is a very small example. If a user logs in and he's the admin, redirect into another page. So if it looked like this, if you click on the event, you get some information about the event itself. You can configure, for example, the condition. So here you can select the user role, and then you can decide whether or not to negate the condition. And then you have a simple form or a simple property thing to configure that specific action. You can also go further. This one is from the Spark module, the other presentation about energy management, and this one is going to fetch data from an API, like a regular JSON output, like, I don't know, energy values, I think it was in this case. It's going to put them inside a queue for further processing in the backend. And then when that queue is being processed, we're going to do some stuff with them. So we're going to take some values, converting from kilowatts to watts, converting to integers, stuff like that. Now we're going to create an InfluxDB point, and then we're going to send that to InfluxDB, right? One simple model, no code behind it, just that, and it works. Very simple to understand. This is something that is in a live website for a client of ours, which is basically like a review model. They have a big amount of articles, a big amount of pages, and they need to be reviewed at a regular interval. So they assign people to those pages, people that are coming from different geological regions in Belgium. So every time that a page or an article is due to be reviewed again, this system will make sure that we grab the necessary articles, that we populate an email for the specific geological location, and then we send that email so that people get triggered to review their article or their page or whatever. This might seem very complicated, but if I show this to a client, he immediately knows what is going on, and he can also talk with me like, but if this should happen, or if this happens, we should make sure that this happens as well. So he sees the edge cases, and I can immediately adapt the model based on those edge cases, instead of going around in circles where he tests it on an acceptance environment, he sees something that he's missing, he goes back to me, I have to adapt it, test again, blah, blah, blah. With this, it's very theoretical, but he can immediately see what is missing from this model, and we don't have to go through it or in a loop every time. So that was ECA, very short. Let's continue with AI in ECA. Of course, you have the AI module by Marcus and various other contributors. I'm not going to go into that much. I think we all know what it is. But what I want to highlight from the AI module are the operation types, right? An operation type is a categorization that the AI module itself has decided upon, and they are grouping various functionalities of different providers or of different LLMs together. The components are a type interface. You can describe what the input is going to be and what the output is going to be, and then you can tag them for logging, rate limiting, and so on and so on. And then it's up to the implementing provider to make sure that it exposes the capabilities that it had. It has to expose the operation types. So these are the operation types that are currently inside the AI module. I mean, the most known ones are chat, image classification, image, speech to text, text to image, and so on and so on. This is an overview of the providers that are actually capable of doing certain operation types. So for example, you see that chat is applied or is applicable by most of the known providers. You see that OpenAI also has a couple of those, like embeddings, what is it there, moderation, text to image, stuff like that. So various providers implement various operation types. These are the ones that are actually being capable of being executed inside an ECA model. So chat, embeddings, moderation, speech to text, text to speech, and then text to image. There's an open issue for that, so if you want to contribute, find me tomorrow. We're going to see some examples of how these different operation types are being implemented into various ECA models. And we're going to begin with chat. I think that's the most obvious one or the easiest one to understand. And what it needs, what the operation type needs, is of course a model, the token input. So besides the prompt that you give it, you also need to give it context. You also need to specify, if it responds, where you should save it inside a token, because ECA is built upon tokens And I don't mean AI tokens, I mean the token functionality of Drupal core with the square brackets and stuff. It's saved into that one. And then some config overrides like the temperature, stuff like that. The output, as I mentioned, is a textual response, and then the use cases are where you can generate, based on the body, you can generate like a text that is suitable for social media channels. So if we implement that into an ECA model, you will see that, for example, if I create a new article, we need to fetch the body value, save the response into another field. So how does this look like? So again, we select the model that is capable of doing that. We specify the token input. In this case, it's the body field. The other ones, here I mentioned that the response of the LLM should be saved inside a response token. So in the end, if I execute this action, I have to use this token value. And this is then the prompt that I provide to the LLM, like I need to convert this body field into something that I can use on social media. Embeddings, this is something that is not so easy to implement or not something easy to grasp, but it's basically something that converts your text into in a vector, so in a couple of numerical collections, as I would call them. There aren't that many use cases for using that inside an ECA model, but one thing that you could build is like a content recommendation system, where you take the value or where you take the node ID and you compare it with others, and then you try to, based on the embeddings of those particular node types, you try to find common touch points, and then you try to make sure that the client is redirected to those. Moderation, that's perhaps more important for web form submissions, where you can let the web form submission be evaluated by an LLM to see if that submission is applicable to be stored or applicable to be handled upon. So here you can see another ECA model where we use the moderation action. We're gonna again use a different model, this time the moderation model from OpenAI. We're gonna give it the body value, we're gonna save the result of the moderation execution inside a token. And then whether or not the content is saved, is that you can see that here. If the content is marked safe by the LLM, we're gonna create a social media text that was the same model as before. If it's not safe enough, we're gonna notify the admin and we're gonna automatically unpublish that node. So here you can see that we're using that moderation token, and it has a sub-value called flag. That's something that's coming from the LLM. And then, if it's, as I mentioned, if it's not safe, we're gonna send a message to the administrator with a specific message, like it was flagged not safe enough. We're gonna give it a reason, and so on and so on. Speech to text, which can be used by, for example, if you upload a video, you can take the audio from that, you can let it transcribe and automatically put that into a separate field. So here again, I have an article, I have a video attached to it. If I load that video and send that to that specific LLM, and if the LLM was capable of executing or extracting text from it, we're gonna again execute the same model as before. If it's not capable of doing that, we're gonna send a notification to the administrator. So here I'm using another model. I'm using Whisper from OpenAI. The token input is a video that I saved on the article, and then the resulting token, I called it STT. In this example, doesn't really matter. You can put here anything you want. It's just a matter of making sure that you use the correct token in any of the other following actions. Text to speech, that's basically the reverse of that. Use cases are accessibility enhancement. So for example, if you have a huge body field, you can convert that to audio by using an LLM that you like, instead of using things like read-speak, where you have an external JavaScript plugin read the text for you. You can do that by using an LLM that you own directly. The counterpart of using models or workflows like this is AI automators. It's something that Marcus created a couple of years ago, I guess, in the meanwhile. I'm not going to go into depth. I'm mostly focused in AI in ECA models. Just want to point out that he also created a huge library of articles where he goes through his automator stuff. Very cool to see. There was a presentation that he gave, I think, in DrupalCon Barcelona somewhere. And these are some screenshots of that presentation. I will share the slides afterwards. There are links in there where you can find them. So that was AI in ECA. Next topic are agents. Again, this is something that Marcus created again with some other collaborators. And it's a framework for manipulating configuration and content in Drupal via AI. Examples are the field type agent and the content type agent, but again, this was explained earlier today. I'm not going to go into depth. You can control these agents via mini Kanban, chatbots, or some various buttons in the UI. This is an example of the mini Kanban, or here, for example, you have a button to suggest taxonomy terms based on the entire value of your article. I think it's in this case. Or for the ECA, you can ask AI to create them, right? Example or an article for looking up how agents work, you can go to this one. That was a presentation from the Dev Days in Leuven in April. So for ECA, there's an agent there as well. The idea was brought up by Dries during his keynote in Barcelona. And it resonated for me. I think that was a huge missing piece of functionality inside Drupal. I mean, ECA is awesome, AI is awesome, but there is a learning curve, and we should not underestimate that. So what I did, I created some building blocks like a data provider repository, and then those things, those plugins, those services, I can then use to let AI create ECA models for me. So this is like a theoretical overview. So you have your LLM at the top, you then have the AI agents module, then you have the ECA agent, and that it can use a data provider, a repository, and a serializer. Those are all necessary. I think with the current set of tools in AI 1.2, there are better ways to do it. As I mentioned, this was created last year at AI version 1.0. So things might have changed. I might need to change my implementation as well, but this is my learning path, so to speak. This is the theoretical type data model that I'm providing to the LLM to making sure that whatever he responds in the JSON format can be validated. This was again at the time that ECA configuration was not yet validatable by core. I think there are steps being taken to actually do that, but I needed something that I could validate, so whatever the LLM gives me back, I can validate it and give the response or the error messages back to the LLM, so it's like a loop where it's basically correcting itself over and over again. The repository, why is it necessary? Because I need to give everything that is already in ECA, I need to give that to the LLM inside its context window, so this is an example of how you can do that. There's a lot that you push inside the window, so this is something, this is the full ECA model, but then in a JSON format. These are applicable events that are available, these are conditions that it can use. This is again an event, but in like a full view mode type of thing. Why, we'll come to that in a minute. But as you can see, if you want to make sure that an LLM can create an ECA model in the best possible way, you need to give it as much as context as you want, but you also don't want to push everything inside that first prompt, because it's a two-step process, so we will come back to that later. So step one is you have to determine the intent of the prompt, right? So it starts with a question, it starts with something that a user provides, and then you have to give it possible actions like create a model, edit a model, give me information, or just fail if the LLM doesn't know what it needs to do. The format decides how the LLM should respond, means that you can give it certain structured ways of how the JSON format or how its JSON format should look like, and then you give it examples. This is the entire prompt, so here you can see that we specify that it's a Drupal developer and that it can create and edit configuration for that specific module. it needs to figure out what the prompt is trying to do. Like, is it trying to create a new model, or is it trying to get information about existing components, stuff like that. So it's very tied to being a Drupal developer working with ECA. This is these are the formats, so this determines how the JSON response from the LLM look like. So you have one action key, you have a model key, component ID keys, and then feedback. These are learning examples that you should give to the LLM. Like, for example, if it determines that the prompt of the user is to create a new model, this is what the LLM should give back to Drupal. Like, action is create, these are the components that the new model should use, so that the next step can actually create that ECA model. This is the edit action. There you specify also the user login ID of that model and the components that the new model should use. Information action, just give me information about what that model is exactly doing, or give me information about these specific plugin types or components, like the user login event, the user or the insert action, stuff like that, if it needs to fail. And then there's the 2A step, or the second step, where it's actually going to answer just the question that the user was asking. So again, this is like a second agent, as Marcus explained. It's in a loop. So this is that second loop, or that second step inside the loop that is going to be executed. This is an alternative step. Instead of answering a question about a certain model or about certain components, it's actually going to do stuff. It's going to build a model, whether or not that's creating or editing one. That's part of the implementation or part of the response. But what's most important here is that validation step. We need to make sure that whatever the LLM gives us back is something that we as coders can convert into an ECA model. Here we're also changing the dynamics. We're not saying that it's a Drupal developer, you're a business process modeler expert, and you're working with the BPMN 2.0 standard. So we're steering away from Drupal, we're giving it the building blocks that it needs, but we're not saying anything about Drupal anymore. And that's important to give the LLM the correct context. Here again is a data model that I was talking about. So you have the model, which is representing a regular ECA model with a name, version, stuff like that. You have a list that consists of plugins, and the plugin can be an event, a condition, or an action, successor, stuff like that. So this is the data model that the LLM should be using or should adhere to. If you want to learn more about type data, I suggest you look at this screen recording of Piotr during DrupalCon Barcelona. And of course it uses the schemata model to create a schematic or a JSON schematic version of that data model. So that's a type data class. That is the JSON schema of the entire data model, and we give that to that LLM. How does it look like? So you have that button here at the top where you can ask the AI to do stuff for you. You then get a prompt or a pop-up window, and I hope this works. So what you're gonna see is that it's going to which one is it? It's gonna ask information about a certain model. So now I'm just gonna show you what the model consists of. Now it's thinking, and then it's going to execute that step 2A, and it's going to provide information what it all does. And that's the way I think clients or developers, site builders can actually use an LLM to get information about the existing models, but also the ones that were created by his colleagues, for example. Then if we want to create a model, that's something more more comprehensive, I would say. So again, that two-step process of figuring out what the prompt is like, what the user is trying to do, and then executing step 2B, where it's actually going to compose that entire data model and figuring out what actions to use, what events to use, things like that, and then it created that one. So we need to enable it, and then we can edit it, and then it will look something like this. So this was just generated by AI, and nothing else was applied. Alright, so again, if you want to create, or if you are the moderator of your own module, try to figure out what a good action or a good agent could be. Tools, gonna go over them rather quickly because I see that we're running out of time. The basic thing, or the most important thing that you should know about tools, is that it's something that your LLM can execute on your website, right? It has the possibility to know, based on the description and the name of the tool, that this is something that it can do and that it can expect a result from that. Various things that you can use for tools, but this is perhaps the most clear answer. What if Bob asks your Drupal site what version it currently is? So you're using the AI assistant for that. Of course, the LLM can try to determine that itself. It can generate a response without actually executing or without actually knowing what it is. But if we give it a tool which executes this one, so Drupal info, we, the website, or Drupal, is going to say to the LLM, okay, my name, this is the name of the website, this is the version that I'm using. The LLM will then respond to that user, I'm running on 11.2 instead of hallucinating something itself. This is perhaps more important or more easy to comprehend. So what if the user is asking the current position of the International Space Station? Of course, the LLM doesn't know, but we provided it with a tool that can execute a backend call or a curl call to, I don't know, an API endpoint. So for example, if we perform a GET request to that endpoint, that external system will respond with a latitude and a longitude. We give that response back to the LLM, and then the LLM can say, okay, the ISS is currently flying over New Zealand. Those are tools implemented by OpenAI or provided by OpenAI, implemented again in, what is this one, Mistral, Anthropic, and so on. Various providers have support for tool calling or function calling. What's important, again, that you give it a unique name, description, and what the input and output should be. So this is an example from AI Core, from the AI module, where you have a function to get the current weather conditions in a certain city, in a certain country, and the units in which the LLM can expect the result to be returned. A little bit closer to home is executing a RAG search. That's also something that the LLM could do. And this is something that the ECA agent is basically doing the same thing as a data provider, but then in an older version. So what about the actions, the Drupal core actions that are already available? They are lacking a clear name, they are lacking a clear description, they are lacking the structured inputs and the structured outputs, and that's why Michael and Marcus created the tools module. So the tool API, which is basically a wrapper or an enhancement of those things that are already in core, but then tailored for AI and other things that it can use. Again, replacement, I hope it gets into core. I don't know when, but I do hope that it reaches that point one day. And then you can have something like this. So for example, you can have a tool that locks a message in a certain way. You all understand that the level that it needs, the message, and so on. The channel, that's all something that is in core, but this is just a wrapper around it to make sure that the AI or the LLM can decide or can know what to do. Same for the system status. You can let that be executed by an LLM, and it will get back some output. Entity loads, again.
Ladies and gentlemen, do not miss the wrap-up of the event at 6 o'clock. This is the time to share the last moment all together.
Okay. We also have a new event called Tool, which is basically something that you can use to trigger an ECA model via a tool call. So if you place that tool event inside an ECA model and you give the LLM the actionable item to actually trigger that model, you have much more control about what the LLM is capable of. Alright, MCP, last part for the wrap-up. So MCP stands for the Model Context Protocol. I'm really excited about this one, not just from an AI perspective, but just from an integration perspective. I think it's the new REST, and we're gonna see why. So basically we can connect LLMs with different applications. It's an open standard and it's called the USB-C for agents, or the cigarette lighter principle. I don't know who still knows what a cigarette lighter is, but it's basically this one. So it's that small thing in your car that if you put your finger in it, it's really warm. You can basically put anything in it, right? You can put something in it that lights your cigarette, or you can put something in that charges your phone. Basically, MCP is the same thing. It's supported by major frameworks like OpenAI in March, Microsoft Copilot, and then Langflow. It was released by Anthropic in November last year. It allows you to switch LLM provider and vendor. I'm going to talk about that in a minute, but do know that there's a growing list of capable servers that expose an MCP server, like Slack, like GitHub, like Drupal then. And at its heart there are, I'm going to skip that one. This is a more clear image. So you have a host with a client, like for example your laptop with Cloud Desktop, for example, and then you can connect it to various external applications like GitHub, like Slack or Drupal, where they have their own layer on top of it. In Drupal that's called the MCP module, and you can connect, or the client can connect to that via HTTP, so regular post requests, or standard input-output. There's also the counterpart in Drupal called the MCP client, where you can use an AI assistant, I believe, that is capable of executing MCP calls to external systems instead of exposing Drupal capabilities. But it's in an experimental phase. The MCP module, it was created by Georgi, I'm not gonna say that, I'm gonna pronounce it wrong apparently, so I'm not gonna do that. By the two Georgis, and it leverages the JSON RPC module. Here is the Model Context Protocol module page, and this is the documentation page on how you can set it up. And there are certain parts of it. So the first one is the resources, and it exposes data and components in static ways. So you can't do anything with them. You just execute it and you get data back, and that's it. And it's all static data. For example, you can get the structure of your content type, or you can get the detail page of a node, for example, or the body values of a node. Then you have, that something looks then like this. So this is the MCP inspector. Here here you get a list of all the resources that are available. Here I have also enabled a plugin that is exposing all the different conditions and events and actions that are available inside this Drupal installation. And then you get an output like this. So here you can see that I am requesting how a very specific node type is looking, what its structure is, so which kind of fields it has, description field, if it's required or not, and so on and so on. You also can get static content, for example a page. This is then what it exposes, like the title and then the body field, things like that. We have prompts. I'm going to skip that one because it's not really applicable. The important thing is that you can also expose your tools via the MCP server. So basically, if you create a tool, if you create something that an LLM can execute on your website, you need to make sure that it knows how to execute that. You can use MCP to make sure that an LLM knows that in a very structured way. So here is an overview of the tools that are available. So you have, give me the configuration schema of that thing, execute a certain action in that particular way. Then you get the same result back as you would execute that tool inside the AI Explorer, for example. Here's a screenshot of how you can execute a tool with some input. So here is the content search tool, where you can specify the amount of items that it should look at, the offset, starting point, things like that. Sampling, I'm gonna skip that as well. The most important thing about MCP, and it's basically IoT all over again, where they said like the S in IoT stands for security, it's the same for MCP. So really need to make sure that whatever you do with MCP, that you are aware that there are some security issues. For example, the rug pull is that if you have set up a certain tool or a certain resource and an LLM is connecting to your MCP server, and in another iteration you're changing your way of implementing that specific resource, that could be an opening gate or a security gate inside your application. We're going to see some examples. So for example, here is you want to execute a tool that is getting the weather for a certain condition, for a certain city, and for some reason you're using eval for this one. So if this is the prompt, what's the weather in, get me this one, your LLM is just going to, your front or your backend code is just going to execute that one. Same thing for the weather. Here you can adjust the description of what it is doing. But perhaps the most important thing, in my opinion, is that MCP is a way to connect AI models to different data and tools. But what if we change it to this? We can change it to literally anything. That's the power of MCP. So what it is intended, it's trying to make sure that you can connect an LLM to your Drupal installation, but what is actually possible is that you can, connect your smart toaster via the MCP layer to your Drupal installation, your bulbs, your light bulbs via MCP to your Drupal installation. And it's the network effect that nobody expected. As I mentioned, in my opinion, it's a new REST layer, where, for example, a developer at Spotify built an MCP server for AI to access it. Your Drupal-powered intranet is capable of connecting to various MCP servers, so it can now create a playlist based on the user tasks at hand. And the beautiful thing is that you didn't need to write any Spotify code. You just connect to that MCP server, you can see what kind of tools it needs or what kind of tools it exposes, and then you build your own code to connect to that MCP server, and that's it. So the Spotify MCP developer doesn't know that your app exists, and everybody wins, and then you can create a new Drupal installation, for example. So in my opinion, MCP is like a new possibility space where everything is possible. We just expose whatever we have, whether that is being executed by an LLM or via another application. That's, in my opinion, the best way forward, or where true innovation lies. I'm gonna skip that one because I think we're running almost out of time. Summary, I think you all get that. ECA is awesome, AI is awesome, AI agent is awesome, MCP is awesome. I'm sorry for going over time.